Welcome to EDU World Space.
So in problem 82, we have a glass rod and one end is flat and the other end is rounded with a radius of curvature of 10 centimeters. And there's an object inside the glass rod that's 15 centimeters from the flat end and also 15 centimeters from the rounded end, from as measured from the vertex to the object. And the apparent depth of the object, which is S primed, is 8.2 centimeters when you're looking from the flat end. And we're asked to find the apparent depth of the object when you look from the curved end. So if you look at the example with the pool, which is example 34.7, you see that when the image is on the incoming side, then S primed is negative. Okay, so since the object is embedded inside this glass rod, which let's say has index of refraction n, the object is inside, I don't know, somewhere wherever 8.2 is, maybe here. So this will be your S primed. S primed is negative because it's on the incoming side of the two media. So we need to keep this in mind. And the way we're going to solve this problem is to use two equations. First, we'll use equation 34 and now it's 34.13, which is NA over S plus NB over S primed is equal to 0. So this is for the flat end. And then for the curved end, we're going to use equation 34.11, which is very similar. So it's NA over S plus NB over S primed is equal to NB minus NA over R, which is the radius of a curvature. And this is for the rounded end. And the reason why they're similar is that you can derive the equation for the flat end from the rounded end by taking R to infinity, and then you get a 0 on the right-hand side. So let's do a couple of things. Well, since the viewing is done on the air side, so this is N and here is air, and this is air. So let's call NA, which will be the glass rod, that's N, and NB is air, so that's 1. So we keep that in mind. And right away, since I mentioned this example here, where you saw that S primed is negative because the image is on the incoming side of the refractive medium, we have that S primed for the flat side is minus 8.2 centimeters. All right, so let me go on to the next page. So I had on the previous page from equation 13, and I'll just put in N over S plus, so that should be NA, but I just changed it to N because that's the index of refraction of glass, and then 1 over S primed. And we do know S and S primed. S is 15, as we're told from the problem, and S prime, we're also told, is minus 8.2 centimeters. And that's equal to 0. And the idea is to solve this equation for n. So n is equal to minus s over s primed, which is 15 centimeters divided by 8.2 centimeters. And that gives me 1.83. Okay, so now I found the index of refraction. And for the second equation, I have, so the second equation we need to solve for s prime, and this is for the curved end, right? So we have NA over s plus NB over s primed is equal to NB minus NA over R. Right, so we know NA, we know NB, we know S, and we know R. And we need to determine S prime. Now, these two S primes are different, right? Because this one is for the flat end, and this one is for the rounded end. So we can go ahead and just solve this equation for S prime, where you find out that S prime is equal to S times R times NB divided by S times NB minus NA minus R and A. And let's go back to our figure here. Okay, so the incoming side is inside the glass. So that means this radius of curvature here is negative, because on the incoming side, when it's on the incoming side, this curve looks concave. So then we have a negative radius of curvature. So that's another thing to keep in mind. And as mentioned before, S prime again had better be negative for this particular case, because we know that the apparent depth should be somewhere inside this glass, again like the pool example. So R is less than 0 or negative. So let's just plug in the numbers now. So we have S prime is equal to S, which we know is 15 centimeters. R is negative 10 centimeters. And NB is just 1. And again, S is 15 centimeters. NB is 1. And NA is N, which is 1.83. And minus negative 10 centimeters times 1.83. And that gives me negative 25.6 centimeters. So that is the apparent depth of the object when you view the when you're viewing the object from the vertex, from the curve side. So this is the distance from the vertex to the image.